Hello and welcome to Camp in 7 Slides. My name is Gilbert Piltz. For those who don't know me, I'm a standards wonk at Oracle. Today I'm going to be presenting an overview of the Cloud Application Management for Platforms, or CAMP specification, along with a demonstration of a proof of concept implementation. Now, if you're familiar with the PaaS landscape, you know that this area of cloud computing has got a number of different providers out there, and these providers support a number of different languages on top of different runtime frameworks using different architectures. But one thing they have in common is that each of them uses a proprietary application management API. And by that I mean the API that you use to deploy your app to their platform, to configure your application to use their services, start your application, stop it, that sort of thing. Sometimes this API is fronted by a command line interface, other times by some sort of web console, sometimes both. Sometimes this API is documented. A lot of times it's not documented, and or the documentation lags behind the implementation. And this situation has a number of interoperability and portability problems. From an interoperability perspective, if you decide for whatever reason that you're not happy with your current PaaS provider and you want to switch to a different PaaS provider, any sort of dependencies you've built on their tools in terms of your management framework is going to have to be changed because the tools and or the API is different. Also, if you want to take your app from like one PaaS provider to another PaaS provider, there's no portable way of representing the context around that application. By context, I mean configuration information, the information about which of your app components depend upon which of the platform provider's services. That information is pretty much proprietary at this point. And finally, this doesn't leave any room for independent tool developers to develop app management tools on any sort of consensus basis. If you're going to try to do for instance, if you're trying to do a Eclipse plugin that could provide any support even a reasonable majority of all of these providers, you would have to do it on a plugin basis by doing different plugins for each provider, and that's not really tractable. And what sort of makes this situation worse is that there really isn't any good reason for it. The value of a PaaS platform is dependent upon a number of things. One of them is the appropriate level of abstraction. Having a PaaS platform that is abstract enough for your customers, but doesn't abstract away some of the details that they may want to manage. The other point is that you want a PaaS platform with a rich and diverse set of services, right? Basically, the richer and more diverse you got, the more attractive your platform is. The other point is you want there's just the sort of nuts and bolts of running an application, right? I need reliability, orchestration, automation, that kind of workman-like aspect of running an application. And finally, of course, you have price performance. How much is it going to cost me to support how many users, right? In all of this, nobody seems to think that the features and coolness of your app management API is important, right? This is table stakes. I need some way to get my application in there. I need some way to configure it. I need some way to start it, stop at that. But if you do it in a very, very cool way, it is not going to really matter that much to me, right? The said no one ever meme breaks out. I chose PaaS provider X because of its app management API, said no one ever, right? It's not something that's really going to help you differentiate. So to address this problem, there is the Cloud Application Management for Platforms specification. This is a specification based on the idea that it probably makes sense to come to a consensus API that would work for most of these providers, manage most of these applications, and we could remove this notion of everybody having to do it in a slightly different way. Now, this specification is currently being processed by the OASIS CAMP TC Technical Committee. This technical committee was formed in August 2012. It's currently got 17 active member organizations and individuals, and I pictured some of the more active members on this page. Now, what is the CAMP specification? So, the CAMP specification has basically two parts to it. One of them is a resource model for representing applications and their components, and an API for manipulating that model. The API is HTTP based. It supports JSON. The only serialization format it supports is JSON, and it's highly extensible. And we'll get into why extensibility is so important later on. The other part of CAMP is the packaging format. So this packaging format currently supports zip, tar, or TGZ. The metadata that describes the application is in YAML, and it also is extensible. Now, the important thing about CAMP is that it is designed to be language, framework, and platform neutral. So whether your application is written in Ruby or PHP, whether it uses Spring, whether it's dependent on .NET, whatever, CAMP should be capable of managing that. Now, what it can do is fairly simple. It can interoperably manage applications and use of the platform. So you can deploy your app, you can configure your app, customize it, start, stop, that sort of thing. And it enables a fairly high degree of monitoring. That is to say, there's not a lot of details in the monitoring, but you can look at your various application components and tell whether they're doing okay or whether they're in trouble. You can see simple metrics like the number of requests per second they're handling, that kind of thing. The other half of CAMP is the idea of portably migrating applications in between platforms. So I want to be able to take my application artifacts and put them in a package, slap some metadata around that package, and deploy it on a platform. And the idea is that any CAMP compliant platform should be capable of processing that package and at least get you started on getting your application running. Now, obviously, there's problems in the areas of if I'm a platform, if I depend upon a certain version of the of a particular message queuing service, and I try to migrate to a platform that does not support that message queuing service, I've got some problems, and those CAMP can't do anything to solve those problems. Now, one of the main guiding posts in CAMP is the idea of being humble. You'll hear members of the CAMP TC refer to it as the humble spec. And there's a number of reasons for this. The main thing is that the PaaS space is evolving rapidly. And if we're going to address this problem of divergent application management APIs, we should best do this quickly. And the problem with a complex spec is that it takes a long time to get consensus around a complex spec. It's difficult to implement them, and there's a lot of interoperability issues. So best to solve a small problem quickly. The other thing is that there's a number of people in the CAMP TC, and there's a good deal of expertise around application management, but there's a lot that we don't know, and we don't know what we don't know. So rather than try to solve all the problems for everybody, it's best to stick to a small footprint. So the strategy is to limit CAMP to a small footprint, to solving a minimal set of problems, enough problems to be worth solving, but not any more than that. And to solve these problems in obvious ways, right? We're not about trying to invent new super cool technology around application management, right? Let's just do the common sense thing to solve the known problems. So part of CAMP, a big part of CAMP is to get extensibility and versioning right. Because we're keeping our footprint small and we know we're not going to be able to solve everybody's problem, we really expect that those who implement CAMP are going to have to extend it to make it fit their particular system. And this is encouraged. We want people to extend it because that shows us where we need to go with our next version. The only thing is to make sure that consumers of the API can discover these extensions and find the documentation to figure out how to use them. So for instance, if I'm a PaaS provider and I'm implementing the CAMP spec and I find out that I have to create an entire new resource to represent a very important concept on my platform, I can do that, and then I can add metadata that will allow a CAMP consumer to figure out, hey, there's this new resource, and this is what it looks like from a JSON point of view, and there's the documentation that'll tell me what the semantics are about it. And all of this is really to set up sort of the virtuous cycles that you'll see in a rapid application development environment where we want to publish the specification, get people to implement it, figure out what we've missed, figure out what we've done wrong, go back, revise, add, and repeat that cycle. And if we can crank the handle on this process quickly enough, we should be able to come up with something that'll work for most people in a way that'll make everybody happy. So we got to the demo part of the presentation here. Let me tell you a little bit about the environment that I'm using. So this is the NCamp landing page. NCamp is a proof of concept implementation of CAMP 1.1. It's not a full platform as a service offering. It is a toy platform as a service offering, but it's enough to flesh out some of the ideas of CAMP. The other thing we're going to be using is a tool that I'm quite fond of called SOAP UI. SOAP UI is a really good tool for testing HTTP-based APIs, because it allows you to send HTTP requests, get the responses, parse the responses, write scripts around the context of those responses, and so forth. There's going to be, at the end of this presentation, a set of URLs to these various tools. So going back to our proof of concept implementation, the CAMP API is like many other sort of HateOS based APIs, and then it has sort of a front door resource, kind of, sort of your entry into the resource model. And for CAMP, that's called the platform resource. So I'm using Chrome with the JSON viewer plugin. It allows you to look at the JSON. So what I've just done is done a get of the CAMP platform, of the NCamp platform resource. Platform resource is, as I said, sort of your entry point into CAMP, and it sort of shows you everything you need to see from the beginning point of view. The main components of the platform that are really important is the platform component templates. Platform component templates are like little recipes for creating instances of the services that the platform provider supports. It's populated by the platform provider, and most of these are not modifiable by consumers. And the other set of interesting resources is the platform components. Now, again, this is a toy implementation, so the only templates I've got is for a Tomcat shared template. So this allows you to deploy your application on a Tomcat servlet container, and the MySQL shared template, which allows you to create instances of a MySQL database. One of these components is already running, the Tomcat shared instance. The NCamp has a single instance of Tomcat that is shared amongst all of the applications that are deployed upon it. So from here as a starting point, I'm going to go to SOAP UI, and I'm going to register my sample application. Let me actually show you that sample application a bit. So the sample application I'm going to be working with is a little thing called Vitaminder. Vitaminder is a vitamin and supplement tracking application. Right now it's built out of a single WAR file that has uses JDBC to connect to a database and is hosted on a servlet container. The PDP is a package that is made up of the WAR file and this metadata, camp.yaml metadata. The metadata here could be a good deal more verbose in terms of requirements and so forth, but again, I'm working with a proof of concept, and this is pretty much what I've got working at this point. What we see is, at the top level we see our application. The application has a single artifact, which is this WAR file. The WAR file depends upon a JDBC requirement and a servlet container requirement. So this is all bundled up into a zip file, which is named vitaminder.pdp, and I'm going to post that PDP file up to the NCamp implementation. Now, this is once this completes, it's a little bit easier to see what happened. Here's the request I sent. So you see this is a post to the platform resource, actually a slightly an extended version of the platform resource, but this is basically the bits and bytes of the PDP. So by posting that to the platform resource, I basically create what is known in CAMP as an assembly template. Here, let me refresh this for you. So there's my assembly template. As you see, it picked up the name Vitaminder from the metadata. So vitamin and supplement tracking. My assembly template is made up of a number of application component templates. Because I have only one artifact, there's only one application component template, and that is my Vitaminder WAR file. As you can see, the Vitaminder WAR file it has a backlink to the assembly template that contains it. The important bit on this is this array of dependencies. And these dependencies, again, reflect those requirements that came in the metadata. It has a connect to requirement, which specifies I need to connect to, use JDBC to connect to a database, and I need a host own requirement. Now you'll see that these requirements are actually matched with platform component templates. So those two templates I had in there have been matched against the requirements. Now because I have a toy implementation, it's pretty easy to do these template matching. I only have one database service. I have one servlet container. If I need a database service, this better work, or I don't have any other options. In a real implementation, it's thought that this matching of requirements to templates would be a little bit more complicated. You probably involve some sort of user input to say, look, you told me you needed to use JDBC to connect to an SQL service. I've got a database service. I got 4 of them. Pick which one you want depending upon your requirements and your pocketbook. But in this, I was able to match them up directly. So given this template for creating an application, this assembly template, the way I would actually start running my application would be to actually post to this URI right here. And if we go to SOAP UI, we'll go to my next test case. And this instantiate Vitaminder assembly test case basically gets an instance of the platform, digs through that response, and finds out the URI of the assembly template and sends a post request to that assembly template. So if we do that, hey, it worked. We go back to our platform resource, we will see that there is now an assembly. So there's our assembly template. This is our actual running assembly. And if we look at our running assembly, we'll see that it is made up of a list of application components. Again, because we have a single WAR file, we only have one application component. If you look at that application component, we'll see that it's the Vitaminder WAR file, or the Vitaminder web app at this point. It's using a database component called Vitaminder. This got created for it when we instantiated it. The database URL is this right here. And it also has a Tomcat platform component. Another useful little attribute in this application component is the endpoint of the application. So we could click on this and it would actually take us to the application itself, the application endpoint. Now this catalog right here doesn't work because I'm still working on supporting additional components that would flesh out the database necessary to make that happen. But that's our application running at that point in time. Now to get rid of a running application or to stop a running application, delete it, you simply send an HTTP delete request to this assembly URI. So if we go to SOAP UI, of course we've got a test case that does that, gets the platform, sends a delete request. If we take a look at this here, we look at the response and the request. Right, there's an HTTP delete sent to the assembly URI. If we go back to our platform, a little refresh here, we can see our assembly is gone. So that's pretty much how CAMP works. Here's the page of links to useful resources. There's a link to the OASIS CAMP Technical Committee, the latest draft of the CAMP specification. This is the public review draft, a link to the NCAMP proof of concept implementation, and finally a link to SOAP UI tool. If you are at all interested in CAMP, I urge you to download the specification and give it a look through. You're free, actually you're not free to, you're encouraged to comment on the public comment list. If you think we've been smoking something or something's wrong with the way we're looking at things, we would appreciate hearing from you. If you want to get involved, if your organization is a member of OASIS, it's very easy. If you're not a member of OASIS, that's not too hard to do either. You can become a member of the CAMP Technical Committee and work on the specification and help us get it right. And finally, if you're interested in implementing the CAMP, please contact me. My email address is gilbert.piltz, my name, @gmail.com. And I would love to hear from anybody who's interested in implementing CAP. And with that, we're done here. Thank you for your time.